Hello, grade 12. In today's lesson, we're going to be looking at organic reactions, question 4 prelim, and we are doing Eastern Cape 2020. Let's get right into the question. So we have question 4. It says, consider the three incomplete organic reactions below. For number 1, we have 2-bromobutane plus dilute sodium hydroxide. Then for number 2, we have compound P reacting with 2 atoms of hydrogen to give us an alkane. Then for reaction number 3, we have a carboxylic acid reacting with an alcohol to give us an ester and compound Q. Now 4.1 says for reaction 1, write down the type of reaction taking place. Now we know for reaction 1, if we are reacting the haloalkane with dilute, this time the keyword is dilute sodium hydroxide, then we know this is substitution. So for 4.1.1, the reaction is substitution. Right. Now 4.1.2 says the IUPAC name of the organic product formed. If this is substitution, we know that we have to substitute the bromine in carbon number 2 with the OH, right? So this makes it butan 2 all. So that's the IUPAC name. Now 4.2 says write down a balanced equation for the reaction taking place when concentrated sodium hydroxide is used in reaction 1 using structural formulae. Ignore the minor product. Now we know one thing. If concentrated sodium hydroxide is used instead of the dilute sodium hydroxide, this is no longer a substitution reaction, it is elimination reaction. Now how do we show this one? So for 4.2, let's draw the 2-bromobutane first. So we have that, our Br in the second carbon, like that. And then remember, this is reacting under concentrated sodium hydroxide. Now what will happen here? The Br will be eliminated from this carbon. Then the hydrogen will be eliminated from this carbon. Now the product that will form is in between here. We'll have a double bond. A double bond in between. Then remember, this Br now will react with the sodium to form sodium bromide. And the H will now react with the OH to form H2O. And that is the balanced equation for that reaction. Now 4.3 says for reaction 2, write down the name of the type of addition reaction taking place. Now what is the name of that addition reaction? We can see that in reaction number 2, we are adding 2 atoms of hydrogen. If we are adding 2 atoms of hydrogen, what is the name of this addition? We call it hydrogenation. It's hydrogenation. Then 4.3.2 says name of the catalyst used. Now what is the catalyst that we use in hydrogenation? It is platinum. 4.3.3 says structural formula for compound P. Right. So to come about with the structural formula of compound P, let's check what is going on here. So how many carbons do we have in our straight chain or our longest chain? We have 1, 2, 3. Remember, this one in brackets is a what? Is a branch, right? Which is occurring in carbon number, it's occurring in carbon number 2. So now we have 4.3.3. Starting off with the parent chain, we have 1, 2, like that. Then this goes like this. We have our branch and carbon number 2. And that is compound P. Now 4.4 says consider reaction 3. Write down 4.4.1, the name of the type of reaction taking place. So remember, when we analyzed, we said this is a carboxylic acid reacting with an alcohol to give us an ester. What do we call that reaction? We say it is esterification. So for 4.4.1, we have esterification. Forgive my handwriting. Now 4.4.2 says one reaction condition. What is the reaction condition for esterification? We know it is that we need concentrated sulfuric acid to act as catalyst. To act as a catalyst, right? Now 4.4.3 says name or formula of inorganic product Q. So we know what is taking place here. From the carboxylic acid, we are taking out the OH, and from the alcohol, we are taking out the H, and this OH and H react to give us this byproduct Q, which we know it's H2O. So name or formula, we have 4.4.3, it's H2O, or you can just write water because they said name or formula. Now for the last one, we have the structural formula and IUPAC name of the ester produced. So remember, to come about with the name, we said you first start naming from the alcohol side, right? So looking at these two compounds, the alcohol is this one. So let's see how many carbons are in this alcohol. We have 1, 2, 3 carbons, right? So this is propanol, right? But remember, from the propanol, what do we do? So we have propanol, we drop the suffix anol, and then we put YL. This makes it propyl, right? And then let's check the carboxylic side. How many carbons in the carboxylic side? We have 1, 2, 3, 4. So we know that's butanoic acid. But remember, when we name an ester, we drop off this anoic acid. And then what do we do here? We have now butanoate, right? So we drop off the oic acid, and now we have butanoate. So naming the ester, the name of the ester now is propyl. The name of the ester is propyl butanoate. Now let's draw that. How do we draw propyl butanoate? So we go Let's start with the butanoate side like they did. So this is 4. Like that. And now we have that oxygen, the ester link. And remember, we have propyl for the alcohol. So, yep, this becomes the structural formula of the ester that is formed, and the name is propyl butanoate. Awesome.